Let's solve a problem using the mean value theorem. We need to find the values of c that satisfy the mean value theorem for the function f of x equals x minus 1 times x minus 2 times x minus 3 on the interval from 0 to 4. Let's start by expanding our function. When we multiply these terms out, we get x cubed minus 6x squared plus 11x minus 6. Next, we need to find the derivative. The derivative f prime of x equals 3x squared minus 12x plus 11. Let's visualize this function. Here's our cubic function f of x and the interval from 0 to 4. According to the mean value theorem, there must be at least one point C where the tangent line is parallel to the secant line connecting the endpoints. By the mean value theorem, f prime of c equals f of 4 minus f of 0 divided by 4 minus 0. Let's calculate these values. F of 0 equals negative 6 and f of 4 equals 0. Plugging these values in, we get that f prime of c equals 6 over 4, which simplifies to 3 over 2. This means 3c squared minus 12c plus 11 equals 3 over 2. Multiply both sides by 2 and subtract 3, and we get the quadratic equation 3c squared minus 12c plus 8 equals 0. Using the quadratic formula, we get c equals 2 plus or minus 2 over root 3. Let's verify these points on our graph. Here are our two c values. At each of these points, the tangent line is parallel to our secant line, confirming they satisfy the mean value theorem. Therefore, we have found that c equals 2 plus or minus 2 over root 3 are the values that satisfy the mean value theorem on the interval from 0 to 4.